C class. So we had started with the capacitors and series and parallel combination of capacitors we had done in the last class. So some basic circuits only we could see. This was one of the good questions that you have to practice at least before coming to the class. So if anybody wants to write it who was absent in the previous class, first write down this question, then only we'll begin with the next thing. So if anybody is there who has not written, please let me know in the chat column. Otherwise, I'm starting with the short circuits, because this is a very important question for you from the board's perspective. See, there are two things that we have.
Can you scroll up for a second?
Yes, Rishita.
Thank you, ma'am. You can scroll down.
Done everything? Fine, class. Now see, when you have these circuits present, no, series combination, parallel combination. So what you've studied in the last class, till the last class, that will definitely come. But when we have these circuits present, sometimes you have heard of that circuit has been shorted. That is, short circuit has occurred. So what is the meaning of that? Short circuit is basically when lots and lots of current is present. Current, actually we are using for the term current electricity, but meaning that lots and lots of charges have come. So see, suppose I have this is a bulb which is present. Now the charges are coming. Q charge is coming, Q charge is coming, and Q charge is coming till here. Fine, Q charge is coming. So once this is coming, what is happening? It is illuminating the bulb. Bulb is glowing with lots of amount of charges. Now what I have done, I have connected the wire like this. Now what you will observe, this is the symbol for bulb in the electricity circuit that you will study. When this wire is connected, what you will observe, charges are coming, and most of the charges, if they go by this pathway, then what happens? The bulb does not glow over here. This is still the bulb. It does not glow over here. So basically, short circuit is when you have put a wire. So what is it doing when you have put the wire along with it? Lots and lots of current, these are coming, right? So now if you look here, when the bulb was glowing, there wasn't any short circuit present. This wasn't present. So this could occur. This is the normal condition. Now, when the wire is being connected, this is called the short circuit. So see class, when the bulb is not glowing, we can say one thing, that instead of having this bulb and this entire setup, can I just have this one simple straight wire? I can replace everything. And if nothing has to occur, I can just replace it with a single wire. The function is same. If I put this wire or this device, both are serving the same function. Right? Now, the second case. Second case is of an open circuit. Open circuit means when the current is actually not flowing. This. So when you have open circuit, no current is flowing. So what you can do? You can replace the wire. So in short circuit, you can replace the entire circuit with a straight wire. Replace it, then only you'll be able to solve questions. This is like a hack. This is like a technique. Replace the entire circuit with a straight wire. Fine. And when you have open circuit, no current is coming, straight away remove the wire. We will see some questions in current electricity, not in this chapter. It's not required here. In current electricity also we have circuits. So that time I'll give you questions from this portion. This is still pending. Questions are still pending. That time we do. But at least have it in your mind because you have to practice questions. And if you have encountered a question which is having this method, so you should be aware. So write it down first. Okay, done. Now, one more method I want to teach you, which is the potential divider method. This also, all these things are valid and will be utilized more when we'll be doing current electricity. That also I'll start today most probably. That is, let me just discuss the potential divider method first. Plus, these are just techniques for your understanding. Don't go into the details of it. Don't go into so much details of these because I'll be practicing every circuit with you. Actually, many things are utilized together in current electricity also. So some portions I divide it for the capacitor part and some portions I leave it for the resistor part. So that all together, and for inductor, nothing is then left. So for inductor circuit, three types of circuits are actually present. Now, what is potential divider method? See, with the same wire, write down the same potential. This is a circuit if I give. Now, what will you do? If you see this is branching occurring, but here also branching occurring. This looks in series, but because of branch, this looks in parallel also. So it's so complicated. So in such circuits, what you can do, go by the potential. Write down the potential of every term which is mentioned. Look, if this is point A, here the potential will be VA, right? And this is potential VA, VA, VA. So here the potential will be VA, right? Now look, suppose this is point B. So from here the potential is VB. So this is VB. And this is coming, this is VB, VB, VB. So this is VB. Now look class, this point was VB. Now see, if this is VB, this will also be VB. If this is VB, this will also be VB. If this is VA, this will be VA, and same wire, this will be. So I am erasing these VA and VB, these two. So that you remember. From here, the potential has divided. Now look class. What is the potential difference of these two? This is VA minus VB or VB minus VA, same thing you can. Here also VA minus VB, VB minus VA, modulus we'll be talking, so both are the same. Here also it is VA minus VB and VB minus VB. We can say that all the potentials are same. All the potentials are same. Class, can you tell me if all the potentials are same, which type of circuit it is? Parallel or series? Yes, parallel or series? Parallel. Very good. This is parallel combination. Potential, see, voltage remaining constant. It gives an idea that this is a parallel combination. So instead of drawing this complicated circuit, you can replace this circuit simply by this look. Now see, if you have this look, this is A point, this is B point. Now at least understanding is easier and you can solve it in the parallel method of combination. So this is one method which I wanted to tell. Valid for resistor also. Same thing, valid for resistors, same thing, valid for inductors. Write down this potential divider method and see, I want to give you one question also. But first write down this. See class, in this circuit, there are 5 capacitors which are present. Now look carefully. When you look at these two circuits, this is not a short circuit. This is also not a short circuit. Why class? Because current will flow from here and it can come at the same level. And even if current is not coming from this wire, current will come through this wire. This is not short circuit. Short circuit is only this. Only this is known as short circuit when you see this condition. So look here, these three, using potential divider method, here you have VA, here you will have VB. So these three are connected in parallel. We have studied about these two. These three, let us make these circuits first. These three. See class, are you getting this fact? These three, the first, second and third, this is exactly what we have studied right now. They are connected in parallel because of the same potential. So these are the three circuits which are 1, 2, and 3. Now let's look at this fourth circuit class. See carefully if you notice at this fourth circuit, this is a case of short circuit. This is a case of short circuit, and I have told you that whenever you have short circuit, you can always replace it by a single straight wire because there is no use to put a capacitor. No current, no charge would be flowing through it. And lastly, you have this fifth one. So fourth gone from our circuit, we just have fifth one. Now look class, capacitance of all these are 3 and this is. Now you can at least solve this. See, they are connected in parallel. So C1, 2, 3 will be C plus C plus C, which is equal to 3C. And then finally C1, 2, 3, this combination and C5, they are connected in series. So you can just have C1, 2, 3 with C5. So the finally 1 by C equivalent will be 1 by 3C plus 1 by C. So this becomes 3C. This is 1 plus 3, 4 by 3C. So C equivalent will be 3C by. Write down this answer. Now, class Wheatstone bridge also, we'll be discussing it in current electricity. It's a part of that chapter register. But just in case if you get a circuit where you see capacitors are arranged in this manner, this arrangement is particularly called as the Wheatstone bridge. Now, what happens in this? Four capacitors or four resistors, these are connected. Now, what happens? One capacitor is connected between the die. Now, there's a condition which we say the bridge is balanced or the bridge is unbalanced. This circuit is called as the Wheatstone bridge. Now, if we say the bridge is balanced, so the potential difference between this point VB and this point VD, this difference becomes zero. Fine, potential difference becomes zero. VB minus VD becomes zero. So if there is no potential difference here, no charge will also be there. Q is equal to CV, no V, so no Q. So what we can do, we can easily eliminate this wire. Now look class, if this wire gets eliminated, how our calculation becomes so easier. Look what we'll have. If we are having, if this gets eliminated, then look, this will be gone. Then what will happen? These are connected in series and these are also connected in series and their resultant are connected in parallel. That's how we solve a Wheatstone bridge. We'll be practicing Wheatstone bridge. We have an entire derivation for the Wheatstone bridge. I'm not doing it here because that's a part of your current electricity. That time we'll be discussing. But this is here so that when you are revising, when you have the notes with you, so you should remember that the question can come from capacitor also. One more thing, class, how can you decide that the bridge is balanced or unbalanced? So take the ratio of C1 by C2. If it is equal to C3 by C4, your bridge is balanced. So balancing condition is C1 by C2 is equal to C3 by C4. These are just small tips for the questions. Just write it down. One last question, this type is there that I'll tell you. First, write down this. Now, look, class, the next type of problems which you can get specifically for capacitors. This is just valid for capacitors and not for resistors. So pay attention to this part because this won't be repeated in the current electricity. Now what we have, sometimes these types of structures would be given to you. Now what we'll do, this is one single plate, right? And this is also one single plate. So what we'll do, we'll connect a battery first towards the end, both the ends. Battery is being placed. So this is positive, this is negative. So if this is positive, this entire plate will make this entire plate as positive. So all the sides are now positive. All the sides are now positive. And this negative will make all these sides as negative. Now what we'll do, we have to identify the plates, our capacitor plates. So look, opposite polarities will be in the series and same polarities will be in the parallel. What is meant by this? This will be understood first. Pay attention here, then it will be clear. See, positive, this is one plate, this is second plate. Fine, this is one, this is second, this is third, this is fourth, this is fifth, this is sixth, seventh, eighth. Fine. 8 plates are there. Now look. One is having just single side, so this is not included. Look at the second plate. Second plate and the third plate. Opposite signs. This makes one capacitor. Let's say their separation is C. This is one capacitor formed. Look at fourth plate and fifth plate. Negative, positive. One more capacitor is formed. Let's say the separation is T. Look at this third one, B, and sixth and seventh. They are also making a capacitor. So third one, this is D. So 3 capacitors are formed in total. So our C equivalent, when we are talking about the C equivalent will be directly 3 times epsilon naught A by. Because for one plate, it is epsilon naught A by T. This is the method to solve this. Look at this question. 1, 2, 3, 4, 5, 6, 7, 8. Now they are connected to the batteries. So again, positive and negative. This is positive, negative. So this entire plate is positive. This entire plate is negative. Now have a look over here. Positive, negative will make one plate. Separation, let's say, is T. Now this is negative and negative. No plate will be formed here. Now look here, again positive and negative. This is the second plate formed. So directly your C equivalent in this question will be 2 epsilon naught A by. So these type of questions won't be seen anywhere else. These are just particularly for your capacitor portion. So that's why we are practicing some different unique types of questions. So series for opposite parallel and same side we write it parallel. This is of no use though, but just write it for theoretical purpose. Now class, last type of questions. Now these are also valid just for the capacitors. So pay attention to this also again, because we'll not be repeating them in the current electricity. Now class, these types of capacitors you will see where dielectric slab is being introduced. But dielectric slab is not complete so that you can use the previous concept of what we've studied. Here, the dielectric slab will be inserted in a manner that it is having two materials. Like you are having K1 here and you're having K2. Now, how will we solve? Best method is firstly charge the plates so that you know which of the plates are having which kinds of polarities. Now, look here class, when you have the area getting divided, see, if you look at this carefully, you will see this is having, suppose, D separation. So this is also still having D separation. So distance has not divided. But if you see the area, if this entire area was A, now on introduction of the slab, this is A by 2 and it is A by 2. So area is divided, it means these two are connected in parallel. So what is C1? C1 is K1 epsilon naught A by D. And what is C2? C2, sorry, not A, it is A by 2 now. And C2 is K2 epsilon naught A by 2 into D. And if you have them as parallel, you will just add them. C equivalent will be K1 epsilon naught A by 2D plus K2 epsilon naught A by 2D. So you can take epsilon naught A by 2D common, K1 by K1 plus K. So these are specifically for this. But if you have the distance getting divided, look like this case. Area of this plate is also A, area of this plate. Plate, don't look at the area, look at the plate. Plate is not getting divided. But see, earlier when this capacitor was a single capacitor, the distance was G, area was A. Now on insertion of both the conductor, the electric slab, this is still A, this is still A, but distance is G by 2, D by 2. So it means these are now in series. So C1 is epsilon K1 epsilon naught A by D by 2. So 2 will go up. Similarly, C2 will be 2 K2 epsilon naught A by D. Why? Because D by 2. And they are connected in series. So 1 by C equivalent will be D by 2 K1 epsilon naught A plus D by 2 K2 epsilon naught. One thing let us do class, C equivalent. Let us take D by 2 epsilon naught A common. So we are left with 1 by K1 plus 1 by K. So on solving this, we'll have D by 2 epsilon naught A. This becomes K2 plus K1 divided by K1 plus K2. So what is RC equivalent? RC equivalent will be K1, sorry, this is multiplied. So our final C equivalent will be K1 into K2 D by 2 epsilon naught A K1 plus K. Write down this part, class. Class, tell me, this is clear or not? Yes or no? Everything, because this completes with this chapter. Tell me, class, everything is fine till here? Khadija, Mariam, Rishita, Zaina, Mariam, Batul. Everything is clear till here? Yes or no?
Yes, ma'am.
Okay, write it down, class. Anything if you have, please ask me. this portion, these last portions, why I extended this class today on this topic only, because these portions will not be repeated. The dielectric slab, that plate formation. Write it down, write it anyways. Class completed till here. This completes with the second chapter. Now I'll be starting with current electricity. On Tuesday, there must be an off due to Eid. So on Thursday, directly we'll meet. Now some extra classes have to be substituted for all of you. So I hope now by after Eid or by the next week, you all will be having your vacation so that we can have the classes in the morning also. So at least on Wednesday, Thursday, Friday, or on Saturday mornings and Sunday mornings, I want to complete this current electricity by the first week of July so that we can start with chapter 4. Current electricity is not a lengthy chapter, it's a short chapter. So we will be able to complete it, but I want extra classes for that. If we go by the normal classes, so we just have 3 classes left in June now. So 3 classes are not sufficient. So I'll take your extra classes after you come for Eid, after you have your Eid vacation, so that everybody will then be having the vacation started. Right now, some of you were not happy. All right, class, you can leave then. Thank you so much for joining.
Thank you.